So we're proving the probability generating function h of s equal to E of Sx. This is the definition, and which is the sum of Sx and E of x from 0, which is equal to, I think we can, you can know what we did about this and go to, so it's Sx lambda x over x factorial e to the minus lambda, which is to the minus lambda s lambda x over x factorial, which we say was e to the minus lambda e to the s lambda, which we can write as e to the lambda s minus 1. So then we find h prime of s to be equals to the derivative of what is in the exponential. Remember that eu prime is u prime e to the u. So the derivative of s minus 1 is 1. So we have lambda here. That's the derivative of u prime. As u is here, lambda s minus lambda, the derivative is e to the lambda s minus 1. So h prime of 1 is lambda. So this we did last time. And now we want to find the second derivative. We want to find the second derivative, which will be the derivative of u here is again lambda. H double prime of s is the second derivative of this expression, is the derivative of this expression, which will be lambda square e to the lambda s minus 1. And the second derivative at 1 is lambda square. So we define the variance of a random variable using the probability generating function as second derivative at 1 plus first derivative at 1 minus first derivative, the derivative at 1 square. So, which is lambda square plus lambda. H prime of 1 is lambda square, which is equal to lambda. So this shows that the mean and the variance of a Poisson distribution is the same. The standard deviation is square root of lambda. So if x lambda is a Poisson distribution. Then the mean of x is lambda, and the standard deviation of x the variance of x is lambda, and the standard deviation of x is square root of lambda. Let's look at some problem we may want to solve. There are a lot of problems here. You will want to play around with them. Let's look at number 94. Let's look at problem 94 and try to solve it. 92 is part of your graded homework problem. Some of these problems are the type when you see answers is a type of actual problems for those who are preparing for. Anthony, you say you have interest in actuary. Maggie too. We are thinking about offering financial mathematics next semester. Dr. Lee was feeling maybe it might be too much, but financial mathematics is just like calculus 1 at the level of understanding. It's not even up to calculus 1 because it's more of using calculator. So I want to encourage her to teach it next semester, as well as you will be taking 305. So as you guys are planning for your Maggie, I am talking for those who are doing actuary. We want to offer. Yeah. Okay. Sorry for that. you know, I've, because I can forget. That's why it came to my mind. I'm just mentioning. Think about it. Discuss it with her. You guys should take 305 and 315. 315 is Financial Mathematics 1. So that during the summer, you will have time to play with it, and you might even find it easier to take Financial Mathematics exam, but you cannot take it after the first class. But you will see what it is. You need a Financial Mathematics calculator. Actually, it's about learning how to use that calculator. Yeah, any solution, Maggie, you want to show us as you are busy thinking about the problem? Okay. Jacob says he doesn't like actuary. You are done with maths. Good. And we enjoy you in our classes, even though you are not. Are you doing double major? Oh, okay, okay. You took real analysis so early. Yeah, it was too early. Yeah. I wish you didn't take it at that time and you have to take it when you have learned more mathematics. Yeah, yeah. Somebody want to do it on the board? So what do we have here? Probability that x equals to 3 equals to probability that x equals to 4. Is that right? I should put what? Is 2 here? Okay. What is 3 about? So this should be 3 there. Or should is 3 there? Okay. So solve the equation. So P of x equals to 2 equals to 3 times P of x equals to 4. What is lambda? You solve for lambda. You know x. I mean, you solve for lambda. Essentially, what you are asked is to solve P of x equals to 2 is equal to 3 P of x is lambda square over 2 e to the minus lambda equals to 3 lambda 4 over 4 factorial is lambda. So what is lambda? Lambda should be 2. We can't take minus because we always assume that lambda is positive. And what is the variance of this Poisson distribution? Two. Understanding the problem is key to solving them in probability. So I want to add some remarks here. The first one is that if we have two independent Poisson distribution, then the sum of the random variable is equal to that x1 and x2 be two independent Poisson random variable. We are interested in knowing what is the distribution of the sum of the two random variables. Then x equals to x1 plus x2 is a Poisson random variable. It's a Poisson random variable, which means P of x equals to lambda 1 lambda 2. This is an important information which, so if you have two random variables that are independent and they are Poisson, their sum will also be a random variable which is Poisson. How do we understand the meaning of the sum of two random variables? Suppose, for example, that two people have an insurance. And the number of claims they can file, that is the number of times, that's if it is health insurance. Do you think that the health insurance of a couple are independent? We just think. Can you assume that if two people get married, then their health are independent? Sometimes they begin to eat the same food, they begin to go to the same type of places, but that is not enough really to say that their health are dependent, because there is so much into people's health than just what they eat and what they drink. Do we get what I'm trying to say here? So when you will be doing modeling, those are the type of questions you might want to ask, and then deciding about that will determine what you get after. So let's assume that they are independent, and an insurance company wants to determine what will be their sum, the sum of their claims, if they are independent. We may be able to check that the distribution of those claims are Poisson. What you do is you collect data and see the results of the data, find a mean, and now begin to check the probability based on the sample you collected. Does it follow the pattern of a Poisson distribution? For some of you who will be, when you will be taking MAT 215, you will learn how to determine if a random variable is from a certain distribution. And even in 305, we learn it more theoretically. In 215, you learn it practically without understanding why you are doing it. So I just want you to know the meaning of the sum of two random variables. So a couple are driving two cars and they can have accident independent of each other. Accident is what we call a rare event. It doesn't happen every day. It doesn't happen for the same individual every month. It's rare, but it is possible. Rare events are the type that goes into Poisson distribution. And then the insurance want to estimate, if I am insuring these two people, how much will their coverage cost me? So the coverage for the both will be the addition of both. That is how addition gets into random variable. That's an example. So when you add the two random variables, are you getting the same distribution? Is a big question. In 315, we are going to learn what is the distribution of the sum of two random variables. But for now, we are going to accept this result as such. Let's look at an example. $95. So we have X2. We have equals to 1. Let's call this S1. If the period changed to 4 weeks, then we now have a sequence of random variables. Make 1. We have X1, 2. X2, X2, 2. X3, X3, 2. So the number of accidents in the 4 weeks period will be what? X equals to sum of the next line. Can we say that? Daisha is not saying what we are doing.
Okay.
Can you see the problem we are solving?
No, I cannot. Sorry, I was on mute.
No, it's not this one. Can you see 93, 96? Daisha, can you see the problem on this? What do you see on the screen?
All right, now I see problem 10, but I have 96 because you had it on the board before.
You are still seeing the whiteboard?
And then 10. Okay, now I can see it. Yep.
Okay, we are looking at 95, not 90, 95. So 95, we have a Poisson distribution with a mean of 2 per week. We want to know what is the probability that there will be less than 5 accidents in 4 weeks. I'm going to summarize it on the whiteboard because I can't have both at the same time. So we have x lambda, where lambda equals to 2 per week. What is the probability that we have less than 5 accidents? Is that right? Calculate the probability that the number of accidents in a 4-week period is less than 5. Probability that x is less than 5 for 4 weeks. For 4 weeks. Have you been able to solve? So you want to find, you want to know that we will say that each week, the number of accidents is a Poisson distribution. Week 1, we have a Poisson distribution, x1 with mean 2 for week 1. Week 2, we have a Poisson distribution with mean 2. Week 3, we have a Poisson distribution, x3 with mean 2. Week 4, we have a Poisson distribution with mean 2. So let x be number of accidents in 4 weeks. And x will be equals to x1 plus x2 plus x3 plus x4. And based on what we did for 2 random variables, the remark I gave you was that if you have 2 random variables that are independent and Poisson, then their sum is also Poisson with the mean, the sum of their mean. If you have 3, you do 2 first and you add the third. If you have 4, you have 3 first and you have the fourth, etc. And you will see that remark that we made for 2 can extend for any finite number, not infinite, finite number of Poisson distribution. So we will say that E of x, the mean of x will be what? 2 plus 2 plus 2 plus 2 equals to 8. So lambda equals to 8. And we want the probability that x is less than 5. So in general, we are not going to complete, you will complete it yourself. P of x equals to k will be 8 raised to power k, k factorial e to the minus k. That's the new distribution. You want to find P of 0, P of 1, P of 2, P of 3, and P of 4. If you have a TI-83 calculator, you can do it. This is not really the way to go about it, but I think there is a binomial calculator, a Poisson distribution calculator. I don't encourage you to use those because on the exam, the actual exam, you cannot do that. So here we have 8. The average rate is 8, and we have x equals to 5. What I'm doing here is using a Poisson distribution calculator from Google, but your TI-83 can do that too. But I don't want to encourage you in doing this because that's not what you will do on your exam. On the exam, you will use a regular calculator with exponential function, a simple scientific calculator. And if you do this, you have this probability. So when zeros, I can help you to know what is the answer, but don't get used to that calculator. Another remark, these are the two remarks that I want us to look at. The second one is that a binomial distribution can be approximately Poisson. A binomial distribution is approximately Poisson under a certain condition. And we just put here that if x and p is a binomial distribution, with n greater than or equal to 100, np less than 10, then x is approximately Poisson. Poisson is the name of somebody, so we write it in capital letter. It's approximately Poisson with mean E of x equals to NP. So on the PowerPoint, where I try to write more professional, we say that if the probability of success is too small, and the sample size is large enough, then a binomial distribution can be approximated by a Poisson distribution. Look at what a binomial distribution is supposed to have. E of x equals to x is n cx dx qn minus x. And we want to say that this is the same as lambda x over x factorial e to the minus lambda. Observe that this one is n factorial over x factorial times n minus x factorial. This is dx to n minus x. And this one is np x over x factorial e to the minus np. This is x. So this is useful sometimes because you might have a binomial distribution with large values, large number of trials, and you cannot use a table. But because we have calculator to do this work, some of these approximations are no more that useful. Before, when there was no sophisticated calculator, this is what was happening. It was much easier to use a Poisson distribution to work on a binomial distribution with a large number of trials. Okay. So I want this is the end of chapter 4. I want to start chapter 5. I will introduce the first part of it. So far we have been dealing with discrete random variables. We learned the properties of discrete random variables, and we studied some of the discrete random variables. So your exam is when, next week, right? Friday. It will be on chapter 3 and 4. We have completed. Take-home problems. How we will change that? When is the exam? There's a mistake on my part. Exam 2 is on the syllabus, is October 30th. Oh, I don't think we can work through what I planned. I always hope we will do that. So I think I was planning exam 2. I was planning that by today we would have completed chapter 5, which we will not. What do you think? You want to add chapter 5 to 3 and 4 and push exam to November 8th? No, let's do 3, 4, and then final exam will be 5, 6. There's no way we can do 7. I will try, but the point is that this course continue in 305, and I try as much as possible to cover more in 304 because some of you are not going to come to 305. When we get to 305, we usually start from chapter 7, sometimes from chapter 6 here, because we want to review before we continue. So let's plan to have an exam in 1 week based on, I will send you the take-home problems this weekend for you to look at it. You will submit the graded homework for chapter 4 on Monday. The take-home problem, you can submit it on Friday, the day of the exam, or you can even use it on the exam, as we did last year. You won't be here the 30th, then we can make the 30th is next week, Friday. We can make exam Monday, is that okay? We make exam Monday. Monday should be the 2nd. The following Monday. Okay. I want to know that I have started chapter 5. So in chapter 5, we want to introduce continuous random variable. I just want to introduce chapter 5. And recall the definition of cumulative distribution that we did in chapter 3, cumulative distribution function. We say X is a random variable. Then the cumulative distribution the ink of my pen is finished. The cumulative distribution, I don't know why it does this sometimes. X is a function f from R to the closed interval 0, 1. From R to the closed interval 0, 1. It is defined by f of x equals to the probability that x is less than or equal to x. The first is the capital X, which is the random variable, and the second is the variable x. We did this last time with the distribution 0, 1, 2, 3. A coin is tossed, count the number of heads, P of x, 1 over 8, 3 over 8, 3 over 8, 1 over 8. Is the cumulative distribution. Then f of x here will be 1 over 8, 4 over 8, 7 over 8, 8 over 8. So we define it as f of x equals to 0 if x is less than 0, 1 over 8 if 0 is less than or equal to x less than 1, 1 over 2 if 1 is less than or equal to x less than 2, 7 over 8 if 2 is less than or equal to x and less than 3, and 1 if x is greater than or equals to 3. This is a cumulative distribution function. And the graph of it is a step function. By doing this, I am already getting into the next slide. It's a step function. 1, 2, 3, 4. Before 0, we have it here. And then at 0, we have it at 1 over 8. At 1, we have it at 4 over 8. And so on. So we call it a step function. So I will give you the remark that if a random variable is a discrete random variable, then the cumulative distribution function will be a step function. And for 3 is 1. I cannot put it here. So, but for continuous distribution, we are going to explain what a continuous distribution is. In a continuous distribution, the cumulative distribution function is a differentiable function. You learned that in calculus, right? Differentiable function. So I'm not going to come back to this. I told you this before. I just want you to remember. A cumulative is a non-increasing function. You can try to, it's a non-decreasing function. It is increasing. If x is less than y, p f of x is less than f of y. Try to prove that for homework. Practice that. Think about sets. If A is less than, if A is a subset of B, the probability of A is less than or equal to probability of B. Remember that B is equal to B minus A, A intersection B. Because A is a subset of B, this is B minus A, union A. So P of B equal to P of A plus P of B minus A. We did this before. That means this is greater than or equal to P of B. Now when I say x is less than y, the probability that x is less than or equal to x is less than or equal to probability that x is less than or equal to y. I want you to see how this can work. That set of less than x is a subset of set less than y if x is less than y. Okay? Okay. We continue on Monday.